Okay, welcome to WorldQuant Office Hours. Let's see, let me go ahead and get configured here. Hopefully everyone is able to view this stream and everything is going in nicely. We've had issues in the past. We're trying to figure out how to fix those, and I've got to sneeze. Hold on. Sorry about that. Okay, so let's see. I think we are currently streaming. Adjust my display here. And we should be streaming. So do let me know if you guys can hear me. We've had issues in the past, so I do want to make sure that everything is going through. All right, cool. Sorry for the delay. Looks like things are up and running. Okay, sorry about that. Let's see. I'm going to go ahead and change something. How about that? That should work out a little better. If you see me why I'm viewing off to the side, is because I have a second monitor. Not because there's something more interesting there, is I have a second monitor with some notes and things like that. So if you see me looking off to the side, I'm looking at the second monitor. I'm still in the game of Office Hours to let you know about that. Let's see who's with us. I see Nelima is here, Soon is here, Jennifer is here, Maxim is here. Let's see who else. Emmanuel is here. I see that Cristian Tejerina is here. Ana is here. Alicia. Ragaraj. Looks like a lot of familiar names and faces. The Bismarck is here. All right. Thank you, Ana, for letting me know you can hear me loud and clearly. And I see Gita is here. Hello, guys. Hello, Lyndon. I put here in our agenda a discussion of functional programming. There are a couple of things that were brought up last time, and we want to go back and finish up functional programming. And I also forgot about heaps. We haven't finished our discussion of heaps. I keep on forgetting about that. Heaps. Wrap up our discussion of heaps and make progress towards the VC mini project, the vector class mini project. Get familiar with writing object-oriented programming and get familiar with best practices when we define our classes. And as always, I'm drinking water, so that's that. All right. Let me know any additional topics for me to throw on the board. Go ahead and start my server. And the discussion I want to wrap up, let's go ahead and new Python 3. I see Naya is here, Omadara is here. Hello guys, welcome to Office Hours. I'm going to rename this to Office Hours October 13, 2020. All right, so the last thing I want to talk about with heaps is that we talked about how they work, why they're better than you when we want to have a priority queue. If you want to make use of heaps, we'll import the heap queue function in Python, and we can have a list. Say my list 1, 2, 3. Well, let's just see 5, 2, 17, 0, 43. And the first thing I do is I need to heapify this list. I need to go ahead and convert this list represented in a way in which I can have this tree like structure that we talked about previously in past Office Hours. And that's achieved through the heapify function. So now my list has been, quote, heapified. And now I'm ready to push in elements. Heap. So if I call in, I say heap queue, heap pop, heap push. If I look at the documentation for that, the heap and then the item. So now that I've heapified my list, I can push in, let's say, -1 pushed in a new element, and it goes ahead and puts in its proper place in this tree. And I can also pop things. I can say heap queue, heap pop my list, and it pops the lowest value. In this case, it's defined as the one that has highest priority is the one with the lowest value. Okay, so that's basically my wrap up regarding heaps. Take a look at the other past videos where I discuss what exactly is a heap and the structure behind them, and here we're actually implemented in Python through this heap module, heapify your list. Then you can call heap push and heap pop. And this right there, the operation is an order log n operation, order log n, which is great. We want those log time complexities. Someone is asking about this name equals main. All right, I think this is a good topic. Name underscore equals main. We will make use of this. We go ahead and work on a project like I mentioned before, guys. One of the things that I want to do as towards the later parts, perhaps the 2 weeks of this course, as we have walked through all the mini projects, is we work on a project together. Work on some sort of data science project, perhaps a web application, a website people can visit. It does something, perhaps nothing too elaborate, but enough for you guys to take that project and make it your own. And we'll definitely make use of these concepts, things like dunder name dunder equals dunder main dunder. So if this is a little bit weird, we will clarify that, no worries. We'll make sure we understand that. Let me know about additional topics to throw on the board. And I will talk about functional programming next, but feel free to throw in additional topics, and then we'll talk about the VC mini project and make headway there. Okay, so in programming there are various, quote, paradigms, various approaches you can program in. And one approach that we're familiar with is imperative. In other words, you work on your operation, you can read it kind of step by step. You do this, you create that variable, you call that function, you have an if statement. Imperative, step by step by step. There is also a object-oriented approach, which we'll talk about in the VC mini project. This whole idea that we can define a class, a blueprint, an outline, a template, and then create objects of that class. You can think of an object as some data encapsulated with tools and methods that work on that data. So object-oriented programming is a type of paradigm, a type of way of viewing and constructing programs using the object-oriented approach. The other approach, another popular approach here, is called functional programming. And I was a little weirded out when I first read about functional programming, because functional, not in the sense that it's practical, pragmatic, functional in the sense that it deals with functions. And we saw a bit of functional programming last time in office hours, although we didn't say, hey, this is functional programming. We dealt with the concept of functional programming previously in office hours when we dealt with lambda functions, anonymous functions, and mapping operations. And we'll go ahead and continue today and talk about reduction and filtering operations that kind of wrap up this idea of functional programming. And we're not going to see a lot of functional programming in this course, but it's important to note it is a paradigm of programming, of coding. And while we don't cover things like big data and Spark is a big data processing engine, a big data framework to analyze big data in a distributed fashion. When you work with Spark, you work with a functional programming approach. So perhaps some of the topics we will discuss here in your later journeys, you deal with, go ahead and have to learn Spark, which is a distributed computing framework. You'll go ahead and we have that seed planted about functional programming. All right, I see a couple of things posted out here. I see, what platform do we use to deploy an application? There are several ways to go about it. We're going to use Heroku. And in fact, if you're interested, I'll show you, this is Heroku here. So what I'll walk you through later on in the course is Heroku. For some reason it's in this. Let me just click here. I don't know why it's stuck on terms of service. I guess I have to accept. Yes, I guess they want me to accept. Yeah, so we'll be using Heroku in this course. So I have a couple applications here. So for example, this is one application I had deployed using Heroku. This model is Bayes' theorem, flipping a coin. All right, see a couple things posted on here. In the algorithms class video, the last exercise, what is the meaning behind $? I was told it was invalid, and why? I'll have to see. In fact, I'm going to take a look at that. I'll put this on the agenda. This $, so I can address it. PY algos. Okay. So we talked about map. And map was a way in we can go ahead and take a function and apply across an iterable. An iterable is just anything we can iterate through. And we say map. So for example, if I have a list, say like my list, I can say map, and I can say lambda x squared. So in other words, we have an anonymous function we're only going to use right now at this one instance, and it will square all the elements of my list. And what gets returned is an iterable. What gets returned is an iterable that I can go ahead and perhaps convert to a list. Take that iterable, convert it to a list, and now I have a list of squares of my previous list. So map, in other words, maps some function across an iterable. What if we wanted to filter out certain values of an iterable and get a new iterable out of it? We can use filter. I can say filter. I have here a function. In fact, I'm going to look up the documentation. Filter, function or none, an iterable. Return an iterator yielding those items of an iterable for which function item is true. So in other words, it's going to apply a function. That function should return a Boolean value that will be used to filter things out. So I can say filter. I can say lambda x, and I can say x divided by, I can say, let's see, I can say true, x divided by 2 and the remainder of 0, else false. And I have my list there. I can say for x, and that, print out x. So in other words, what I did with filter is I took this function, and if I read this function is, do this, if this is true, then return true, else return false. And I applied this function on every single element of my list, and I only kept those that satisfied this criteria. And sure enough, I notice I've only printed out the even numbers. So now we can also combine things like filter and map. We can take this output and we can go ahead and apply a map operation. In other words, we can say map lambda x squared and apply that to the output of this filtering process. Say for x, print out x. So now we print out the square of the even numbers. So I can take the out iterator that comes out of it and it becomes the input of another of these operations. Notice we're working with functions. This is functional programming. We're working with pure functions, functions without any side effects. So let me know if there are any questions people have regarding the use of filtering and map here. And notice we're also making use of anonymous functions. I'm going to use a function. I'm only really use it one time. I don't want to define a proper name function. I just want to make use of it at the point of creation, and that is it. Let me know if there are any follow-up questions. All right, I see Tim is here. I guess I don't speak German, so I say Guten Tag, right? Good day. All right, glad you're joining for Office Hours Live. All right, let me know if there are any follow-ups regarding using filtering in a map. Someone's saying, can we watch this video later? And the answer is yes. These are recorded. Office hours are being recorded. In fact, we have a playlist of past office hours. So if you go into your pod and you go into video links, all the way at the bottom, we have a playlist. Open it up, and we put all the past office hours. In fact, we use a thumbnail so you can easily navigate and understand which video you need to watch. So if you, oh, this one talks about enumerating tuples, so you'd watch it because it deals with enumerating tuples. So yes, we do curate this playlist. All right. I see someone is saying, do you feel this last example pushes the boundaries of Zen? Simple is better than complicated. And I believe the answer is yes. Can I choose one number on the list and square it? Let's see. Yeah, and Kinsha, you can ask questions here. I can put it on the agenda. Okay, so going back to what Jeff is saying. So yeah, I think simple is better than complicated. If I look at this here, this seems to be a rather, doesn't seem to be as readable. So we're pushing the boundaries of simple is better than complicated. Keep in mind that we could have used list comprehensions or sort of comprehensions to have achieved this, and that's probably the better approach here. You could have done this here, but I would suggest that we use comprehensions instead. So we could say for x in my list, and we say if x divided by 2 is equal to 0, and then square my list. So that would have been, in my opinion, the better approach. So thank you for Jeff for bringing that up, the fact that, hey, sometimes you do something, you have to step back and reflect yourself. Is this readable? Is this too complicated? Was there a simpler way? And the answer is yes. And well, the lesson here is that Python offers this functional programming approach, but it does sometimes feels a bit clunky to work with it in Python. It's not a functional programming first language. Someone's saying, can I choose one number in the list? Yes, you can, as long as your filtering condition is able to filter out that number. Or filter everything else to only keep that number. Now we'll talk about reduce. All right, I see some people are first time live in office hours. Oh, welcome. Now we'll talk about reduce. So let's go ahead and talk about reduce, and then we will go ahead and work on the VC mini project. But do throw your agendas on there. So now, reduce, and we'll see this. This is one of those things where if you go on to big data using Spark, you're going to do a lot of reduction operations. Let's say we have an iterable. We have an iterable of of tuples, 1 and 1, 1 and 2, maybe 0 and 3, and 4 and 5. And what I want to do is I want to sum up all the values of the tuples by their corresponding index. In other words, what I want to do is I want to add 1, 1 plus 1, 1 plus 0, and 0 plus 4. So 1 plus 1 plus 0 plus 4 is 6, and I want to return 6. But I also want to do 1 plus 2 plus 3 plus 5. So 1, 2, 3, that's 6 plus 5 is 11. So this is what I want to get out. And let's say you have a stream. Maybe this list is very large. Maybe it's distributed onto multiple clusters. We won't be doing distributed computing in this module here, but some of the things we'll be doing right now in this example are going to lend itself if you work on distributed computing using Spark, this idea of map and reduce. So notice I want to take this data structure and reduce it down to a smaller entity, the sum of their corresponding indices of the tuples. That's what I want to do. So let me go ahead and do here. I'm going to say my proverbial, I'm going to call this data. I always call it my list, but let's call it data. And I forgot what I had there, what I wrote out in the board. 1, 1, 1, 1, 1, 2, 0, 3, and 0, 3, and 4, and 5. So now, what I want to do is I want to go ahead and add this number to 1, add 1 to 2, and so forth down the entire data structure, down the entire list. So I'm going to go ahead and from functional tools, import reduce. Let's use this reduce function. And what this reduce function wants, it says, hey, give me a function, and I will use that function across my data structure. And then provide me the iterable, what you want to be worked upon. So we'll go ahead and leave this blank right now. We'll flesh out this function here. And this function is going to accept 2 arguments, x and y. In fact, I'm going to say, I hate the x and y distinction. I'm going to say accum and val. Where accum is the result of applying this function previously, the accumulation, and val is the next entry. So, at the first pass, accum, what will happen is accum would be the tuple of 1 and 1. This is accum. And the next value, 1 and 2, is val. So to start this off, the accum variable will be this tuple, 1 and 1, the first one, and val will be the next entry, in this case 1 and 2. And my question to you is, can you write out a function in which the first argument is accum and the second argument is val and return 2 and 3? In other words, at their corresponding indices. How would you write that function? How can I write this function? I, J, and enumerate accumulator. All right, go ahead and let me know the rest. We can always assume this accumulator will have two elements, 0 and 1. Well, let's try this out, right? Let's try this out. I can say accum is equal to 0 and 1, and val is equal to 1 and 2. So I can say accumulate, yeah, exactly. I see Tim, exactly, right? I can say the following. I can say accumulate 0 plus val of 0 is accumulate 1 plus val of 1. And I get 2 and 3. I get a tuple with the updated results. So now what happens is that as you do that process, the next value of accumulate, ACC, is 2 and 3. So now we have 2 and 3 is accumulate, and the next val is the next one in the sequence, 0 and 3. We apply the function that we described, that process we described, to get 2 and 6. So our new accumulator value is 2 and 6, hence the name accumulate. It's accumulating the results, applying that process across the data structure. And then we repeat the process. We got 2 and 6 as our accumulator, and 4 and 5 is our next value. And we get 6 and 11. And since we're at the end, it terminates. So we go back here, we can say reduce accumulate val, and we just copy and paste this right there. Hit reduce, and we get our answer. 6 and 11. So notice how we took this data structure and reduce it down to a single entity, hence the name reduce. And the function that does that reduction is described by this lambda function. And it goes through and eats across the data structure. Let me know if there's any questions up to this point. By the way, this finished loading right there. This is a web application that I created. We're in pure Python. Well, there's some JavaScript, by the way. But it's supposed to simulate Bayes' theorem, flipping an unfair coin. So I do want to, when someone asks, what platform did I deploy this on? Heroku. It's completely free. You don't have to put down a credit card. So towards the end of the class, we will look into building some application using the knowledge we've learned and other additional skills as we go through office hours. Why did not we write out reduce, accumulate val? I see. So plus equal. So why not we said plus equal? I see. So why not something like this? And keep in mind that, well, I can prove it here, that this here is we're updating our tuple. We cannot do item assignment. So this here, remember, this here is equivalent to the following. But notice we are updating. This will cause an error because we're updating. Does not work because we are updating the value in a tuple. And tuples are immutable. Right? You cannot change what's in the slots. Someone say, well, we could have done this in a for loop. Yeah, we could have done this in the for loop, but this says this is using the functional programming paradigm. In fact, I think if we were to do this in a for loop, let's go and compare the same result. We could say for pair in data and say something like, we could say result, say 0, 0. All right, and we say result equals result 0 plus, let's say, data 0 result 1 plus data 1. And type error because I'm violating what I just talked about. Unsupported type int and tuple. Oh no, because I forgot. Let's see. Not data. Pair. Should be pair. Pair 0 and pair 0. Pair 1. So yeah, we could have done it in for loop. This would be the equivalent. or we could have taken this reduction approach, this functional programming. Someone is saying, where do we get these notebook files? And if you go here onto Video Downloads Office Hours Notebooks, there are all the notebooks that I upload after the fact. So where they are, Video Downloads Office Hours Notebooks. Probably should have worked as well, but I think it's not the shortest, smartest one. So yeah, I wouldn't say it's definitely not the shortest one. It's a different way of thinking about it. And in fact, this type of thinking, if you go into Spark, which is a distributed computing framework, it works with this idea of map and reduce. Map is where you take a function and you map it across a data structure, apply it across the elements of a data structure. Reduce is all about taking those results of a data structure and reducing it down to a single entity. Let's see what other things here. Yeah, you can write very succinct code in Python. All right, let's see. How is reduce different from map? Yeah, so reduce, I may have already answered this, but map, we keep the same, we still have an iterable. I can say map, and I can say lambda say x, and I can say maybe x squared and x1 squared. So it's going to square all the elements. I can say data, let's say for x in map, and print out x. Syntax error. Let's see what my mistake is there. So map takes a function, applies it to every single entry of the data structure independently. Reduce is it reduces down those entries to a single element. So now let's talk about distributed computing. Let's say you have a big data set that you cannot process in a single computer. So what you do is you distribute chunks of that data to different components, different computers in a cluster. And you send to each of those clusters, you send them a set of instructions saying, hey, apply or map these sets of instructions to your piece. Do it to your piece that I gave you. And then we can take all those pieces and then bring them back together and reduce it down to a single result. And that's how kind of distributed computing works. So of course, a lot more complicated than that. But here we're giving you a bit of a taste of this map and reduce, this functional programming approach. That's going to be, if you go onto Spark, go onto big data, distributed computing, it's going to come in handy. So I'll plant that seed and hopefully it will nurture and grow up. But I think that concludes our discussion of functional programming. So let's go ahead and take a dive into the VC mini project. Do let me know if there's any follow-ups. I do want to take care of those as well. So go into Python mini projects, the VC mini project. Of course, as we go through, we'll talk about different approaches, alternative approaches, and best practices. And remember that a class is a template, outline, a blueprint, a recipe that we follow to create an object, which is the entity, the realization of that class. So here, we're going to depict a point object. And a point object has two attributes. It has an x and a y. Let's go here. We can have a Cartesian coordinate system, and we have a point. And this point has an x value and a y value. Okay, someone's saying, can I break this down? And yeah, I can break that down. We will make sense of it when we get to it. So yeah, I do plan to break that down. Let's understand what's going on there. So all right, so we want our class to have two attributes when we create an object of that class. So we pass x and y. So then we say, okay, our object has an attribute called x, and it has an attribute called y. And now we want to, let's go and run this here. Let's try this out. pt equals point 1 and 2. Let's print out ptx. Let's print out pty. And let's print out pt. I get 1 and 2. And if I print out point, I get this message of 0 and 0. And the reason why this does work out, the reason why this doesn't work out, is because if we look at this special method, and it's a special method because it has the name of double underscore, some name, and double underscore. Double underscore for shorthand is called dunder. So dunder, REPL, dunder. This method is called when we print an object and it returns a string, and this is a string that is depicted when you print out that object. So right now it's just printing out 0 and 0. We want instead is to print out the actual x value and the actual y value. So any suggestions on how I can fix up this REPL method of my class, let me know. And let me look at the chat here. So the key differences between functional and object-oriented programming. Object-oriented programming likes to deal with state. You have an object, and that object represents some sort of state. It has some sort of data, and that can be updated. Functional programming is all about accomplishing things through pure mathematical functions without a side effect. And when we do with distributed computing, or when you go on to work with distributed computing, we don't want to keep track of state, because keeping track of state across our cluster is difficult. So it lends itself to use a functional programming approach where you don't keep track of a state. You work with pure mathematical functions. All right, so I see a couple things. Format, string format. Yeah, so let's try that out. And I like to use these F strings. I like to find them better than the previous approach, the previous Python approach of using format. So I use F string, and what I have here in curly braces is the value we want to put right there. So we say self.x, so the object's x attribute and the object's y attribute. And keep in mind the grader will complain if there is no space there. So now I get 1 and 2. All right. Someone's saying, can you talk a bit about the difference between a leading and trailing double underscores and a single underscore methods? Yeah, let's talk about that. In fact, I think we'll talk about that when we flesh out this add subtract method. It lends itself that discussion a little bit better there. We can also explain what the hell is going on in this function here. All right, so that should work out. Any questions about this first question here? Trailing, yeah. I figured it meant trailing double underscore, yeah. And then, yeah. And we'll go flesh that out in exercise 2, Q2. Questions about Q1. Keep in mind that I could have also done it using format. I could have said point x and done format. I could have done this here. It would have worked just fine. However, I prefer this one here because it leads to a more readable solution. I can read it from left to right, and I know what goes right there and what goes right there. This one here, I only know it at the end, but both would have worked out. Yep, Naya, you are correct. That would have also worked out. And let me just prove it to myself. I get a name error because it's self.y. I had a comma for some reason, and that works out. 2 different approaches. Pick whatever you like. All right, let's see if there's any follow-ups. I'm going to go and move on to Q2. So now we want to add and subtract methods. So these here are special methods. And the reason why they're special methods is because they have they have a double underscore at the beginning and a double underscore at the end. And specifically, Python will allow us to use these special operators like plus and minus. 1 plus 1, we get 2, but notice we can also use plus operators on two strings. We can use a plus operator on two strings, and what it returns is a concatenation of our two strings, DACL and cat. DACL cat being a palindrome. All right, flip it around, and it's the same word. Someone's saying, what is the difference between an object and a class? A class is a blueprint. It's like a set of plans. This is how you create a car. This is how you construct a house. That's a class. An object is the actual car or house, the actual realization. So that's why we define a class, and then we create objects of that class. So here, plus, Python can use this plus operator on different objects. And we can use a plus operator for our custom classes. However, we need to tell Python what does it mean to use the plus operator and what does it mean to use the minus operator. So we got to specifically flesh out the add and subtract, dunder add methods. So we're going to try that out with our point class. I will go ahead and copy this here. The reason I'm copying and pasting is because I don't have to write everything else from scratch. And what does it mean to add 2 points? Well, if we have 2 points, 1 and 2, plus 2 and 3, we add the corresponding components. So 1 and 2, 2 and 3, so that gets 3 and 5. And if you were to subtract them, 1 and 2 minus 2 and 3, well, we subtract their corresponding components. We get -1 and -1. Okay. So let's try that out. Let's first define the add method, def dunder add dunder. And it's going to accept self, but it's also going to accept other. So self, we look at here, self would be the first argument, other would be the second argument. So in other words, what I want to do here is do something like point 1 and 2 plus point 2 and 3. I'll copy that. I'm going to just move that down. So the first one is self. The second argument of the plus operator is other. So now my question to you is, what should we return in this method here? Let me know, how do I best construct this adding process? I'm going to take a look at the chat. Someone is asking, what is the effect of introducing case on a class? Can you elaborate what you mean by case? Do you mean case sensitivity? Let me know. I'm confused about that, but do let me know what you mean by case. And how should I write this method? And what I want to do is I want to return a new point object from the addition. Yeah, it's just like the accumulated val question. Yeah, exactly. So let me go ahead and take a look at that. Yeah. So what I can do is I can say return, I can say self.x plus self.other plus x. I'm going to do this in multiple steps. I can combine this all in one line. So I can say x and new. X new is the self.x plus other.x. Y underscore new is self.y plus other.y. And then I return a point object using the updated x value and the updated y value. So let's try that out. I can call this pt and then print out ptx, print out pty, and print out print out PT. That seems to have worked out. Yes, so this here is a special method. When Python, what is happening is that when we execute this line of code here, Python says, oh, you're using the plus operator, so that means I'm going to look at this object's definition, its class definition, which is right here, and I'm going to use the dunder add dunder method. Notice we could have done the following. We could have said pt1 equals 0.1 and 2, and done pt1 dunder add dunder, and said, let me just create pt2, 0.2 and 3. We could have done this. We could have invoked dunder add dunder directly. However, the power behind this, defining this method, is that we can make use of the plus operator. And this is a lot nicer to read than this approach here. So yes, it's a method name that Python knows what to do with it. It knows to use that when we use the plus operator. Let me know if I need any follow-ups with this add here. Can I write x self.x new? Let's see. Where exactly would you write self.x new? Let me know. Keep in mind we want to avoid doing this here. We want to avoid doing this, because if we were to do this, then that means that the object, this object here, I'm creating a new attribute. And I don't want it to have the new attribute. I only want it to have x and y. However, I want the derivative, the output of the addition, to have those values. So maybe that's what you're referring to. I would not do this here. Don't do this. This will add a new attribute to our object, which we don't want because it's returning a new object that actually has x, y, and x new. Any follow-ups with this here? If we've done this, right, okay, I see what you mean there. So if we've done this, then what is happening is that our object will have a new attribute called x underscore new. But we want to have the up, we don't want to change our two objects. We don't want these 2 point objects to change. We just want them to, when we add them, to return a new entity, which has the x new and the y new. All right, so thank you guys for helping each other out. Someone is asking in the REPL, why do I need to keep the same code? I need to keep the same code in the REPL because I wanted to do the same thing. I want when I print out that object, it shows me its x value and its y value. So that's why I keep the same code. All right, I'm going to go ahead and move on. So now we know how to define add. We could, this will go into other people's, some couple of discussion points that I've been reserving. I could say x new equals self.x, other.x, y new, self.y minus other.y, and return a new point object with x of new and y of new. I can do that, and I can run that cell there and run this operation here. However, while this works out and we'll get the correct answer, my question to you is, what is wrong or what is not ideal about what I've just written? It will get me the correct answer, but what is not ideal behind it? I want your opinions before we talk about how we can make this better. We can make use of some of the things people have asked questions about. One important, while you go ahead and consider it further, one thing I want to introduce here is one important concept of programming is called DRY. Do not repeat yourself. And the reason we don't want to repeat ourselves is because if we have code that's duplicated across our code base, we fix one here, we may not forget to fix this one here. It's better if it only occurs once. So, are we repeating ourselves here in a way? We can do, someone's saying we can do maybe some sort of if clause or some sort of, notice how we're, and a couple points is that we could have just not had defined these variables. That's could have true. We could have just said, had the addition right there directly. However, we create these variables, they're gone after we call the method. Can we call the add function with the second value as negative? Correct, right? Addition, so let's talk about math. Subtraction is just a special case of addition. Right? It's just what it is just negating and then adding. In other words, 1, 2 minus 2 and 3, it's the same thing as saying 1 and 2 plus negative 2 and negative 3. So fundamentally, subtraction is the same as addition with an additional step, where you negate the second argument. So here we are repeating ourselves. Let's try not to repeat ourselves. So maybe a better approach is let's create a method that will be used underneath the hood. The user is not going to be aware of it. That will negate our point object. So in other words, I'm going to call this method called negate. And what it will do is it will return a new point object with negative self.x and negative self.y. And notice I named it with an underscore in the beginning. I'll explain why we're doing that. Someone's asking why we return point. So here is we're creating a new, this here returns a new point object. So notice we carry out the operation and return a new point object. Remember how to create new objects from a class? Name of the class, and then inside of it, in the parentheses, are the attributes of that new object. So notice here we have this method which will return to us a negated version of our point object. So that now what we do, if we were to write this down into multiple steps, is negate other, and then call dunder add dunder, the plus operator. So self plus other negate, and that's what we return. So notice we're still we're just modifying, we're not repeating ourselves. What we do is we take this other, which is a class point object, we call the negate method, which returns a new point with the coordinates negated, and then we call add. So let's try this out. I'm going to run this here. Let's try it out. I get a type error. Bad operand type unary on point. So let's figure that out. So dot others, let's see, negate. We call on self, and let's see. Mistake here. I forgot the decimal, a point, not a comma, a point. So let's try that out, and I get the same answer. So let's examine further what we did here. Is we basically did addition, however, we created a new method. And this new method takes the x and the y and returns a new point object. So this here, I'm going to put a little docstring, return a new point object with the coordinates negated. Yeah, so it still goes through two functions, so to speak, right? However, the approach why this is preferred is because we're not repeating ourselves. So imagine this here is a rather simple case, but imagine if we had a bug in our addition method. And we fix it there, we fix it at one place. And maybe our sub was just copy and pasted from addition. Maybe our sub method originally was just a copy and paste of this method here with some things changed around, and the bug might exist in two places. So we fixed the bug in one, but did we fix it in the other one? Now, if there's any problems, any updates I need to change, then I can just focus on one place. Yeah, so do we actually call add dunder just by including the plus symbol? That is correct. And that is the power behind the dunder add, these special methods in Python, is that when we use something like the plus operator, it goes ahead. This is equivalent to saying self.dunder add dunder. That's the equivalent of it. So Python sees that plus operator, and this is what it invokes instead. I'm gonna go 5 minutes over today because I know I had a little trouble starting up. So I will go 5 minutes over, and I want to kind of clear up some points. So notice why we have an underscore at the beginning of this name. That's called underscore negate. What does this mean? Do we need it? And the answer is we don't need it. In fact, I can erase it and just have this, and it works out. So it's not necessary. However, it's a convention in Python. In Python, there are no things as private and public classes. If you're not familiar with this concept, that's probably fine. It appears up in other programming languages. But in short, a public class public method is a method that the user should invoke directly. It's public. Anyone can make use of it. A private method is one in which people shouldn't use. When you write your code, you shouldn't be using those private methods. And the reason why you shouldn't use those private methods, it's because they deal with internal behavior of the object. It's like if you were to go into a museum, and museums, you know how sometimes they have an interactive exhibit? You can think of those interactive exhibits as public methods. Hey, if you're in the museum, play around with it. Poke around with it. Play it out. Try it out. I trust you to do that. But of course, the museum would not be happy if we were to open up the door that says employees only, go in there and start playing around with things. Those are private methods. Those are private operations. I only want you to focus on what I expose to you, the public ones, The private ones don't work with, because maybe I'm tinkering with things in the background that if you invoke, you may not know how to properly use. In fact, when I release a Python package, I say, here are the methods you can work with. Yes, there are more methods, but don't worry about those because those might change in the future. You can work with them, but you might run into trouble. Only work with these public methods. And the way you can signify a public method in Python is if the name doesn't have an underscore in front of it. Private methods are those that have an underscore at the beginning. So while Python tends to give you a lot of freedom, Python says, hey, you can call private methods. You can call private methods. However, you really shouldn't. And to signify to the user that we perhaps are invoking a private method is if it begins in an underscore. So Python won't say don't use it. It just says be careful. It's really a private method. You shouldn't be playing around with it. So that is the significance of a underscore at the beginning of the variable name. If I have two underscores, this is a really private method in Python. And I'm just going to return, this is private. Stay away. So if I define my class here and I create my point objects, and I could say pt negate. I can do this. Sorry. That works out. I negated it. However, if I really wanted to call really private, I have to give it, I always forget how this looks like, so we'll go ahead and let me try this out. Point, sorry. There it is. If I really want to make use of that private method, that really private method because it begins with two underscores, then I have to say underscore, the name of the class, double underscore, really private. So that's, you can't, well, there are things you can do other things to restrict access, but this here is sort of pretty much a large barrier to use those methods. Because in order for me to use really private, double underscore really private, I need to write out underscore, the name of the class, and then the name of the method. So that makes people kind of stay away. Stay away, don't use these private methods. You can get in trouble. You can break things. Only use the public methods. So we're out of time, and we can pick up the discussion later. There's more to talk about with these methods, but hopefully this at least addresses some of these issues of what's the significance of a underscore at the beginning of a method name. So a single underscore means it is a semi-private method. You probably shouldn't be using it, but if you do, go ahead and use it. It's just underscore in the name. Double underscore, it's really private, so you have to write a little bit more to make use of it. And hopefully that's enough deterrent to avoid you using those private methods. Can we do VC5 tomorrow? We probably can, given our pace, given how fast we're going through this mini project. We'll probably get to that. Let me know any quick follow-ups here. I didn't get to this discussion about dunder named dunder, so we can talk about that tomorrow. It kind of lends itself, since we're talking about double underscores. Which of the office hours do we use? Not sure about what you mean by that, but tomorrow's office hours happens at 12:30 UTC time. Same link. The same link as we've been using before. If there's any issues, I'll try to get to that as soon as possible. Any quick questions here? If not, we'll go and pick this up tomorrow, and I can re-talk about this privacy thing, because I know I kind of rushed it towards the end. Yeah, we share the same office hours links for Unit 1, Unit 2. It's just that when Unit 1 is going on, Unit 2 isn't going on, and vice versa. All right, guys. Thank you for your questions. We'll pick this up tomorrow. And with that said, have a good rest of your day, and see you tomorrow.